We're going to continue our study of sets and logic by looking at categorical logic. We need to start first with what are called quantifiers. So when we have what's called a categorical statement, what we're doing here is we are expressing how two sets relate to each other. Now, you might have the word some or phrases like there exist or at least one with these categorical statements. These are called existential quantifiers, and they would help us understand things like some mammals are antelope, to know that there are some mammals that are antelope, but there may be some mammals that are not antelope. Some crayons are not blue. That would also be a categorical statement because that's telling us that there is at least one crayon that is not blue. Now, we also have these universal quantifiers, and that's like saying none, no, all, or every. So we use none and no when we need to deny the existence of something, and we use the words all or every to say that every element of a given set is going to satisfy a particular condition. I highly recommend using Venn diagrams when you are trying to convert these categorical statements into a representation. So these are not technically Venn diagrams, they're actually called Euler diagrams because Leonhard Euler was the mathematician who used these diagrams to look at valid and invalid arguments. So looking at the four types of statements that we are looking at, all, no, some, and some are not, you would have your four different types of Euler diagrams. Let's look at the all P's or Q's. This means that every item that is an element of P would also be an element of Q. So we'll draw P as the smaller circle, since we know that all of those are contained in the larger group Q. Then we know that if there was a particular item that was a P, then we would draw a dot there, and that dot, you'll notice, is in both the P and the Q circle. Now, looking at the next diagram, this is the no P's or Q's. This tells us that if you are in the P group, there's no way you would be in the Q group. There's absolutely no overlap. So an item that is in the P group would be only in the P circle. The next one, some P's are Q's. Some, we will overlap our circles to show that there are some items that are in both groups. So you would draw your dot there in the middle to represent that you know there are some individuals or some objects that exist in both groups. And then the last one, some P's are not Q's. It would be an overlap again, but this is telling us that we know that there is at least one object that's in the P group that's not in the Q group. So looking at an example here, if we wanted to draw an Euler diagram for the statement some chefs are French, then we would draw an overlapping Euler diagram where one circle represents chefs, one circle represents French people, and we know that there is some overlap, that we know that some chefs are French. That overlap, you could think of that being your French chefs. Now the next statement, no historians like politics, then we will not have any overlap. We will have a group of historians and we'll have a group of people who like politics, but there will not be anybody in both circles. Now be careful when you are interpreting these statements. I am not going to claim that these statements are always true statements. So if you disagree with a statement, that doesn't mean that you shouldn't draw it the way that you see it. It just means that there was a false statement and that's okay. We're going to draw it as given.